better as far as how statistics is taught, and if anyone has comments on Bob's initial question here.
So I think that one of the most basic things is that we should really teach what Neiman and Pearson have proposed, and that alpha and beta should be selected to inversely relate to the risks of false positive and false negative decisions. And that would be a rational thing, while any fixed, we should simply abandon the 5%. There is probably no situation where 5% is appropriate. And it doesn't make sense to teach something that's never appropriate.
Well, let me raise a different point of view. I would argue that, in fact, Neyman and Pearson are at the root of the problem. And this goes back to something that was stated in the article several times, that making an automatic decision is often not relevant for science. And in fact, that's generally not what we are trying to do. I would say even the fact that we are trying to publish what we're doing and what we found indicates that we did not just make an automatic decision. We're actually trying to convey information to other people and to convince them. And so anytime we are dichotomizing the results of a trial or any type of study with p less than alpha or not, we've thrown out a lot of information. And that is, I would argue, a more fundamental problem than just how we pick alpha. It's throwing out all this information and acting as if we are making an automatic decision when what we're really trying to do is convey evidence to other people. So there are two very different perspectives on the role of Neyman and Pearson here. So would anyone care to comment, or Knut, would you like to respond?
I totally agree, and that was why I said, and that's where I disagree with Gerd Gigerenzer, that it is not necessary in a publication to make a decision prior to the publication, because the p-value is one way of conveying information. And everybody reading the information we are putting out there will have a slightly different situation where this might be applied or not, whether he wants to accept that and act on it, or would rather like to ignore it. And so to make the decision whether to accept what's presented there or to ignore it, there are two types of errors we could make, and at that point in time, the person reading should have the freedom to decide what are the risks in that particular situation and make a decision accordingly, whether to accept the information or to ignore it.
I agree with, can you hear me?
Well, yes?
I agree with Knut because, Knut, I'm sorry, because the p-value is just one piece of information, and there should be other information presented, like, for example, two-piece graphs or whatever. You know, there should be other information going along in the p-value. Also, the actual level of the p-value is important, and I don't think that it's necessary to pre-specify what is going to be a significant cutoff. That's important, of course, for the sample size statistical power calculations. But I don't think that they cannot present the actual p-value just because they might think that that 0.05 or below might be considered to be significant. And I also agree in what Knut said, that in some cases where, for example, there is a disease that may not be lethal, but and the drug could potentially be very harmful, then when you're doing screening tests, then you want to specify a very low p-value. In other cases, you might use a higher p-value for significance. But again, that's only part of the information that should be presented in the paper.
Well, I should choose the example in GWAS first because I think it's very relevant, and it's also the p-values there serve a purpose. They help us to rank the hypothesis with respect to which set of hypotheses we might want to pick and to move forward with testing the underlying biological principle that is being suggested. And there cannot be, at least in my opinion, a preset level before you really have to see where do you have still more genes that fit into the same concept, and where do you not have that anymore, where you're diluting your concept and don't have a hypothesis anymore. So it is something where the cutoff cannot be pre-specified, but is driven by the information that we have in the data. And I think focusing on this, now it's not 0.05, it's 10 to the minus 7.5, and everything that's 10 to the minus 7.4 would be disregarded. It is as nonsensical in that field as it is nonsensical in other fields.